Welcome to the Fast Track RFID Certification Review, where we will discuss regulations and standards. Standards are created by standards organizations. They can be government or non-government, and non-compliance may affect the ability to use the products, but does not have legal consequences. Regulations are created by governments and may vary between different governing authorities such as state, federal or national, or a group of nations. They usually apply within the physical boundary of the regulating authority and are legally binding. Non-compliance usually has legal consequences such as fines. Mandates are created by organizations to achieve some goal. They usually increase efficiency, reduce cost, and create better product. Non-compliance may affect your business relationship with that mandating organization. Let's review ISO 18000 air interface frequencies. There are 7 frequencies that are covered by this standard: less than 135 kHz, 13.56 MHz, 2.45 GHz, 5.8 GHz, 860 to 960 MHz, and 433 MHz. So why do we have so many different frequencies? Mostly because some of these are legacy frequency allocations that have been assigned to RFID frequencies throughout the history. And also, another reason are the laws of physics. This is because different frequencies are reflected, refracted, and absorbed differently by various materials, and read range varies with frequency. Tag antenna size and manufacturing method also varies with frequency, and therefore each frequency has different characteristics and operation. Therefore, we need different standards for each. So at the 18001 covers generic parameters for the air interface for globally accepted frequencies. ISO 18002 covers parameters for air interface below 135 kHz. ISO 18003 covers parameters for air interface at 13.56 MHz, which is high frequency. ISO 18004 covers parameters for air interface at 2.45 GHz, which is a microwave frequency. ISO 18005 discusses parameters for air interface at 5.8 GHz. However, this part has been withdrawn due to lack of global acceptance. ISO 18006 covers parameters for air interface at 860 to 960 MHz. This is ultra-high frequency and one that we will be discussing more later. ISO 18007 covers parameters for air interface at 433 MHz, which are active tags. Like I said, 18001 covers generic parameters for air interface and basically discusses what is the conceptual system of the architecture for RFID system, defines framework for communication protocols, system management, control and information exchange, and make sure that there will be a highest degree of interoperability between the technologies that follow these protocols. The main reason is to avoid contention or interference with other RFID systems. ISO 18002 covers air interface communications under 135 kHz. It specifies physical layer for communication between the interrogator and the tag, protocol and commands, and method to detect and communicate with one tag among several tags, otherwise known as anti-collision. This standard defines 2 tag types, type A and type B, and they differ by communication and also by frequency. Type A tags use the same channel for both ways of communication between tag and interrogator, and they operate at 125 kHz. Type B tags use 2 different one-way channels for interrogator to tag communication and operate at 134.2 kHz. Interrogators are usually capable of communicating with tags of both types, and the anti-collision feature is optional. Here you really have to remember mostly that the ISO 18002 covers air interface communication under 135 kHz, which is low frequency. ISO 18003 covers communication at 13.56 MHz and provides specifications for physical layer, anti-collision, and communication at this frequency. Mode 1 is based on ISO 15693 with modification for item management. It has slower data rates compared to Mode 2. Mode 2 allows for higher speed and memory and allows for up to 423.75 kilobits per second for interrogator to tag data rate. You don't have to remember the data rates, just know that the Mode 2 is much faster. Reader has to support either Mode 1 or Mode 2 and optionally could support both. ISO 18004 defines air interface at 2.45 GHz, which we call microwave frequency. It defines the forward and return link parameters for technical attributes such as operating frequency, channel bandwidth, maximum EIRP, modulation, duty cycle, data coding, and bitrate. There are again two modes of operation, Mode 1 and Mode 2. Mode 1 covers passive tag operating as reader talks first, and there is not much activity in this area. There are not many technologies that use the Mode 1. This technology provides range more than 3 feet. Mode 2 covers battery-assisted tag operating as tag talks first, which are basically active tags. They provide range over 300 feet, and these are the tags, or this is the technology that's mostly used within this frequency. ISO 18006 covers communications at 860 to 960 MHz and allows for use of different frequencies in different regions. There are 3 versions, version A, B, and C. The difference is the encoding method and collision arbitration method. Version A uses PIE for forward link and probabilistic aloha anti-collision. PIE means pulse interval encoding. Version B uses biphase modulation and Manchester encoding for forward link and binary tree for anti-collision. Both use biphase space FM0 encoding for return link. Version 3 is the one that has been ratified in 2006, and it is based on the EPC Global Class 1 Gen 2 standard. It uses Q factor for anti-collision and is used the most for UHF communications today. ISO 18007 works at 433 MHz, and these are RF tags that are active. These are used by U.S. Department of Defense, usually for container tracking, and by Universal Postal Union. There are also ISO standards that cover 13.56 MHz in addition to the ISO 18003. ISO 443 A and B proximity systems cover cryptographic authentication. 14443A is the most widely used contactless standard in the world, mainly for transport applications. It is used by 2 products, MyFair, supplied by Philips and Infineon, and version A of PicoPass, supplied by Inside Contactless. ISO 14443B has a number of advantages over the A. It has no patents on communication coding, it's widely adapted by reader manufacturers, there are higher communication speeds of up to 848 kilobits per second, and it has been adapted as national standard by many countries. There are also additional standards for 13.56 MHz, and this is ISO 15693, also known as vicinity cards, general purpose applications. This standard expands the communication range from vicinity operations to around 1.5 meters in gate configuration. So as you can see, this standard covers a longer range of high-frequency communications. In proximity operations, ISO 15693 doubles the communication distance of ISO 14443. This standard also significantly reduces reader costs through simple design, and it has been adopted by access control applications, and it's currently penetrating other markets. The only drawback is lower communication speed. There are also some standards for item management. Some of the ones that you should remember is the ISO 15961 that covers data protocol and application interface, ISO IEC 15962 data protocol, which covers data encoding rules and logical memory functions, and ISO IEC 15963 unique identification for RFID tags. Don't mix this up with ISO 15693, which covers the vicinity cards. Let's look at the RFID regulations. For UHF RFID tags and readers, the regulations encompass the following factors, such as frequency, field power, bandwidth usage, channel and channel spacing, and duty cycle. Here you can see a worldwide map of RFID UHF frequencies that are used in different regions. As you can see, US and Canada uses 902 to 928 megahertz. But for instance, in Europe, they use 865.6 to 867.6 megahertz, and in Japan, 952 to 954 megahertz. Some countries use two frequency bands, such as Singapore, Vietnam, or Hong Kong. When you are installing or designing a system for a specific region, you have to be aware of these regulations and make sure that your devices comply with the frequencies, power, and other regulations specified by the authorities. Ultimately, the user is the responsible party because he or she is the one that can be fined by using a system that is not approved. Regulations are expressed in EIRP, which is effective isotropic radiated power, and this is based on the spherical radiation pattern of an isotropic emitter. Real antennas do not radiate uniformly in all directions, and the power is usually radiated only within a certain direction. This gives you the antenna directivity or gain. EIRP power levels related to the dipole antenna, and the relationship between the gain of an isotropic and dipole antenna is given by this equation. EIRP equals EIRP times 1.64. The difference is approximately 2.2 decibels. So this is why when you look at the limit for US, where the limit is 4 watts EIRP and Europe is 2 watts EIRP, you cannot really compare these two power levels. It's like comparing apples to oranges. If you convert the limit of EIRP to EIRP in Europe, you will see that their limit of 2 watts is actually equivalent to 3.28 watts of EIRP, as opposed to in US we have 4 watts EIRP. Main regulatory organization in the US is Federal Communications Commission that regulates the RF transmissions and use of radio frequency devices. The Part C deals with intentional fixed radiators, and Section 15.247 specifically deals with RFID devices operating at UHF frequencies. It defines operation within the bands of 902 to 928 MHz, 2400 to 2483.5 MHz, and 5725 to 5850 MHz. In the US, UHF can be used without a license for between 902 to 928 MHz. However, it has to be within 4 watts of EIRP of transmitted power. FCC Part 15 also regulates low frequency and high frequency. It has regulations for all RFID frequencies. You have to remember the Section 15.247 because it has 9 paragraphs and they provide different specifications for using of radio frequency devices. The paragraph A regulates the frequency hopping for conventional and digitally modulated intentional radiators, which are the readers. B governs maximum peak conducted output power. C defines operations with directional antenna gains greater than 6 dBi. D provides limits on RF power emitted outside the frequency band. E specifies power spectral density of digital modulated system. F defines hybrid systems. G covers frequency hopping, spread spectrum, and channel hopping. H covers incorporation of intelligent within frequency hopping spread spectrum. And I provides the limits of exposure to radio frequency energy levels. The limit for various frequency bands is based on the use of antennas with directional gains that do not exceed 6 dBi. If the antennas have gain greater than 6 dBi, the power has to be adjusted in order to not to exceed the limit of 4 watts EIRP. In Europe, the standards are provided by the European Telecommunications Standards Institute. It has established 2 regulations for UHF operation, which is EN 300-220 and EN 302-208. And it also provides regulations for HF operation, which is EN 300-330. Let's review the newer regulation, which is the ETSI 302-208. It establishes communication for 865 to 868 MHz and divides this frequency band into 15 channels, where each channel has 200 kHz. This band is divided further into 3 subbands, where the middle subband is from 865.6 to 867.6 MHz and allows EIRP up to 2 watts. The rest of the subbands are 865 to 865.6, which allows only 0.1 watt, and 867.6 to 868.0 that allows only half a watt of EIRP. All bands require listen before talk for communication. Here is the summary of RFID regulations in the UHF frequency band. You can see regulations for US, Europe, Japan, India, and Singapore, but every country or region has their own. As you can see, they have different frequencies, different bandwidth, channel spacing, and maximum allowed power. There are also safety regulations. FCC Part 15 247I provides limits of exposure to radio frequency energy levels. The International Commission on Non-Ionizing Radiation Protection, that's allowed to World Health Organization, specified that frequencies under 10 MHz can have effects on central nervous systems due to electric current flow in the human body. So the exposure to low frequencies cannot be time average. Frequencies above 100 kHz can have a warming effect on the human body. This can be time average. There are also military specs. The safe dosimetric parameters for exposure to RF fields is 0.4 watts per kilogram for controlled exposure and 0.08 watts per kilogram for uncontrolled exposure. So this ensures at least safety factor of 10 below the body-specific absorption rate, which is 4 watts per kilogram. So for instance, 200-pound person would have 7.1 watt safe exposure, and 110-pound person would have 4 watts of safe exposure. Safe distance from UHF antenna has been defined as 9 inches. There are also ATEX regulations. The ATEX directive consists of 2 EU directives describing what equipment and work environment is allowed in an environment with an explosive atmosphere. US equivalent of ATEX are explosion-proof Class 1 Division 1 and iSafe or intrinsically safe ratings for devices that operate in defined areas. Class 1 Division 1 is an area where ignitable concentrations of flammable gases, vapors, or liquids can exist all of the time or some of the time under normal operating conditions. Class 1 Division 2 is an area where ignitable concentrations of flammable gases, vapors, or liquids are not likely to exist under normal operating conditions. You can have hardware that is certified Class 1 Division 1 or Class 1 Division 2. That means it is allowed to be operated in that particular area. IECEx is an international electrotechnical commission that sets standards for equipment operating in explosive environment. Then we have HERO standards, which are hazards of electromagnetic radiation to ordnance, Tempest, a National Security Agency specification, and NATO certification referring to spying on information system through leaking emanations, including unintentional radio or electrical signals, sounds, and vibrations. Another standard is IP standard, which is ingress protection, and this is not a protection of people, but it's protection of hardware. The IP number is composed of 2 numbers. The first refers to the protection against solid objects, and the second against liquids. The higher the number, the better the protection. So for instance, IP67 means that there is total protection against dust, and the device is protected against the effect of immersion between 15 centimeters and 1 meter. You can see these IP ratings in specifications for various hardware devices. In this module, we reviewed RFID standards and standards creating organizations. We discussed ISO standards, regulations, and safety standards.